So here's example 2. I want you to give it a shot and see if you can find all 3 parts. I'll scan down to the third one in a second and see if you can't find the answers. Hopefully not having to imitate what I just did in the first example, because it is pretty much identical, but understanding, going through it and making it make sense so that you can do any variation of this on a quiz or test. So go ahead and pause it, give it a chance. Try it on your own. It's okay to make mistakes here. This is a safe place, but on the quiz or test, you don't want to make those same mistakes. So make them now if you're going to make them. Let me give you part C real quick, and I'll highlight all the important pieces that they gave us at the beginning. Radius of 15 inches, angular speed of pi over 12 radians per second. So writing those important parts down, that would be a radius of 15 inches and an angular speed, which remember is that new part. We're going to use that omega W looking shape as pi over 12 radians per second. Okay, so given that, we're going to have to find an angle formed in 10 seconds, distance along the circle in 10 seconds, and then the last part, C here, the linear speed in inches per second. All right, so go ahead and pause it and give those a try, and then we'll come back through and I'll walk you through them very quickly because it is so similar to the first example. All right, hope you did well on that. Very similar, like I said, to the previous example, but I just wanted to give you another example at it because it is a little bit strange with all these new formulas and using a lot of the new symbols that we've been learning in this chapter and in this class. So I wrote down all the new parts over here for us just to make sure that you guys have them. The angular speed is theta over time. The linear speed has 2 different forms, the arc length over time or the radius times the angular speed. So these are the ones that we're going to have to use quite often, but in this first one, which one is the only one that has theta in it? That's this one. And since I want theta by itself, remember we would just multiply over by t to get that to cancel, and therefore we know theta is equal to omega times t. So as long as we know those 2 things, we multiply and we're done. We have our theta. So the omega for this one was pi over 12 radians per second. And then our time was, for this example, 10 seconds. And if you notice, what ends up happening is the seconds cancel out. And then since we're multiplying, we can also cancel the 10 and the 12 by 2 to get 5 and 6. So multiplying straight across, we get 5 pi on top and just 6 on bottom. And the rest of the units canceled out, so it's just radians. We knew that because it's in pi for an angle. Right? If you want to write it, fine. If not, no big deal. Part B, they asked us to find the distance traveled. Well, distance is not one of these new formulas. It's an older formula. It was the rate times the time. The rate, not the radius. Okay? So to find the distance, we're going to need our rate times a time. We obviously have that 10 seconds as our time again, so we'll go ahead and put that in there. But do we have a rate that we are traveling? Yes, they also gave us that. It was that pi over 12 radians per second. But remember, we wanted something along the circle on the outside. This is talking about the inside distance traveled. So we said, unfortunately, we could not use that in that form. So we still want that rate, but we want it on the outside. So how are we going to do that? Well, remember, we said the easiest thing to do would be to use our other form. And we had 2 of them, S over T or R times W. Which, remember, this was a radius and this was our angular speed, and we have both of those things. They didn't tell us anything about the arc length for this one, which we know is the radius times theta. So we're definitely going to use r times w. So I'm going to use my radius times my angular speed, and once I have that, then I can finish. And the radius they told us for this one was 15 inches, and the angular speed again was pi over 12 radians per second. Putting everything in fraction form allows me to then start canceling the seconds from top and bottom. That's a 1, and that's it. No other units, don't need radius, so the answer is going to definitely be so many inches. How many? Well, I know I can cancel the 12 with a few things. I'm going to go ahead and do it with the 15 first because I like multiplying by tens. So 3 goes in this 5 times, and 3 goes in that 4. But then I can cancel the 4 into the 10 as well. 2 times and 5 times. So the only thing left on bottom is a 2. The only things left on top are 5 and 5, which is 25, and don't lose your pi. So that would be our answer for part B in the distance we traveled. If they asked us instead of an exact answer for an approximate, what would we use to approximate that 3.14159 button pi on our calculator? All right, hopefully you got those so far. Last one here was part C, and that asked us for the linear speed, which remember, there were 2 of those, the S over T or the R times W. Just again, remember what all of those letters represent. S for arc length, R for this time is a radius, the W is that new one, omega, we use for angular speed. So the linear speed, we're definitely going to use the 2 things that we know. Again, that would be the R and the W. And the radius they gave us was 15 inches, and the angular speed was pi over 12 radians per second. Again, before you take the time to go and multiply this, make sure that you get what they wanted, and that was that linear speed, which is this, in inches per second, which is why radians are so powerful. We don't even need to write their units, it's implied, and we can use it as an angle measurement or a real number like 3.14. Okay, pretty cool. Cancel. 3 goes in that 4, that 5. So my final answer here would be 5 pi over 4 inches per second. And that's how fast any point they're calling P on the outside of this specific circle with radius 15 inches traveling at that rate of pi over 12 radians per second would travel in a distance, inches per second. All right? So hopefully you got those. There's really only one other type that we're going to see, and again, there could be different variations of these formulas. Just make sure that you're comfortable with them and know what everything represents. So here's the third and final example. Very short section, yes. A belt runs a pulley of radius 5 inches. So right then and there, I know the radius is 5 inches at 120 revolutions per minute. 120 revolutions per minute. Now, if you want to abbreviate that, a lot of people have seen this before. They just didn't know what it actually meant. RPM. Just like miles per hour represents how many miles we can travel in 1 hour. Revolutions per minute means how many times we rotate around a full 360 or 2 pi per minute. Okay, so those are the things that they gave us to work with, our radius and our RPMs. How are we going to use them? Well, this first part asks us to find the angular speed in radians per second. So you have to have that memorized. What is the angular speed? Remember, that was this one. That omega, that W. And it was equal to theta over T. And you're looking around and you're looking, I didn't remember anything about an angle, or they didn't give me anything about time this time. So do me a quick favor, take 60 seconds and pause it and try and think, how are we going to solve this without those two unknowns to find the one that we want and need? Go ahead and pause it real quick and give it a try. Did you come up with anything? Were you able to figure out that we don't necessarily need just these formulas to find the speed of an angle? We don't need just theta over the time. They actually told us how it's rotating around. That was 120 revolutions per minute, but remember, they wanted it in radians per second. They wanted it to look a little more like this and not like this. So what we need to do is then take that 120 revolutions per every minute, and we need to, as I mentioned many times before, multiply by that fancy looking 1. And remember, we can do this as many times as we need to. And I need to get rid of the revolutions and the minutes and change it to radians on top per seconds on bottom. So the first thing is, I'm going to start with what we're most comfortable with, and that is minutes and seconds. So I want to get rid of the minutes, which means I need to put it on top. It's not always on bottom to get rid of it because it's already on bottom. But I do want the seconds on bottom. So what's the direct relationship so that I can multiply and get that fancy 1? Well, you know, in 1 minute, there are 60 seconds. And right then and there, that will cancel things out and allow us to get part of what we wanted, the per second. Now we need to get rid of the revolutions, which, because it is where on the top, we're going to have to put it on bottom to cancel it out. And do you know what I want to get on top? Well, they told us we want it to be radians. So do I know a direct relationship between radians and revolutions? Well, you should know that 1 revolution around is equivalent to how many radians? Hopefully you came up with 2 pi. And that will allow us one last time to then cancel out what we needed to, and that was the revolutions. And notice the only things that are left on top are radians, on bottom, seconds, which is what they asked us to find. So of course, all we're going to do is cancel what we can, and I'm going to go with the easiest, and that 60 goes in this once and that twice. So the only things that are left that aren't 1s on top are 2 and 2 pi, which is 4 pi, and everything else on bottom is 1, so I don't even need a fraction. So my answer to this is 4 pi radians per second. So a little tricky. I hope that some of you actually were able to think when I asked you to pause it for 60 seconds that this angular speed they asked for was just in a different form. The unit measurements is what we had to change, and we had to multiply by 1 twice in order to change it to this, which is what they requested. So this last part, part B here, go ahead and pause and try it on your own. If not, I'll show you how to do it so that you can then try it on your own in the homework and quiz before you get to a test question that could be like it. So this time, linear speed is what we're looking for. And because it's linear speed, we know that we have 2 different variations, the S over T or the R times W. And if we have those 2 things, then we're done. And if you notice, they did give us those 2 things. We don't need to use that one again. We will simply use the radius times the angular speed. And because they gave us the radius was 5 inches, and the angular speed was 120 revolutions per minute, but we just found it in the better form that we're used to, we can rewrite it as 4 pi radians per second, which allows us to finally cancel out and get our answer of 20 pi inches per second. That's it. I was going to do another one that's similar to this, but I think it's a little bit more straightforward, pretty easy, other than the fact that part A didn't use a formula at all. It used a different form of the angular speed, and then we were off to the races. So short and sweet, just like my wife. Hopefully you guys got this one pretty simply, and now you can go practice before we move on to the next chapter, which is graphing. Farewell, everyone. Take care.